We have seen some of the components, some of the principles, how we can make use of those in system designs. And we have seen those principles, like we have seen availability, reliability, but we have seen only a higher picture of it. Now, what we will do on this session onwards is we'll get into more details of it for each and every core principles, and we'll also look at the components differently, like in a later sessions. Let me first talk about the first principle that we are going to discuss today is availability. So, what is availability is you can see here I've just put one small picture 24/7. That means something that is available 24 hours, 7 days. So I got this definition from one of the book and I put it here so that we all can go through it. And I'll also try to explain that what is exactly this availability is. It is the system, it is the time a system remains operational to perform its required function in a specific period. It is a simple measure of percentage of time the system, machine, or service is remains operational under normal conditions, and as well as it also takes into account all the other parts, like we have to maintain the system, we have to repair something, we have to have spare or maybe other logistic consideration. So that's a pure definition of availability. And what is our goal is to see that our system should remain highly available all the time. Okay, so that is uh, a book definition, but I'll try to explain in my own words is that suppose if you're using Instagram, if you're using Facebook, some other system which millions of users are using nowadays, and if that application maybe around late night you open that app on your mobile or your laptop and you see that it is not working, you're not able to open Facebook page or maybe Instagram, and you're trying it again and again, maybe it's early morning, maybe it's mid of day, anytime you try and it is not working, it is not opening, you're not able to see it. So that means that particular time, that particular system, whether it is Instagram or WhatsApp, it's not available to give you that service which they usually provide. You're not able to view any of the page. So that means it is not available. And why availability is so important is there is a biggest impact if the system, a system that is used by millions or billions of users, if that system is not available, it will be a very huge impact to the business itself. So you look at down here, I put some recent news and as well as some years back news, where you can see here our social media platform, which we use maybe daily, Facebook or Instagram. It has a significant outage. Outage of what? Nearly 2 hours. The system was not available. Facebook and Instagram and other services were not available. And according to Bloomberg, you see that it resulted a decrease of 2.2% in net worth of Mark Zuckerberg. And what it amounts, it's 3 billion US dollar. Just imagine what is the impact of a system not available for approximately 2 hours. So that's the biggest impact to the business itself if your system is not available. Similarly, the other example I mentioned here about Google, like we use Gmail, YouTube, Google Drive, Google Meet, Google Docs. So this system, almost in year 2021, it was down for half an hour. What happened? The reason was it was because of Google user ID service was down. There was some issue, some bug. And but due to this half an hour outage, Google lost $2.3 million. So that's the impact if your system, which is used by all over world users, if it is not available, it will impact your business and it will also impact your users. So that's the crux of availability. So your system, whatever you design, you should keep in mind that your system should be available. And for that available, we have to do multiple things. Like I mentioned here, how do you achieve high availability? So we have seen some of this, that we have redundancy of different components. Maybe we have multiple servers so that one server goes down, other system server will keep on providing you the service. We use load balancer. See to it that all the server will get equal amount of requests. We have seen failover mechanism. One server goes down, other server will take over all the request. Disaster recovery. We have seen the disaster recovery in multi-region, like why replication happening from one region to another region. We have seen scalability, how we can scale our system, whether it is web servers, whether it is database, or whether there are other components with active and passive mechanism. The system is scalable. We have seen vertical scaling, horizontal scaling. We will get into those also in detail. But these are some of the strategies: monitoring, analytic, and performance optimization of different components or the overall system. This makes your system highly available, and that is what the goal of system design. Why we design is only to see to it that our system is available most of the time. Okay, so that is about the definition, the impact to the businesses, how we achieve the availability and all. But we have to see that, see, there is, whenever a Google cloud provider or AWS or Azure, whenever they make an agreement, like if you have a website and which you want to put it on cloud, there will be a kind of service level SLA, they call it service level agreement, which we usually sign with those cloud provider, and that has some kind of uh, I'll say kind of agreement between you and the cloud provider, where they will give you, we can provide you availability up to this uh, criteria, and that criteria is called availability, the nines of availability or availability in nines. So before we'll get into that, let's look at the formula of availability and then we'll look at the availability in nines, what exactly the meaning of it. So formula, just to figure it out, how much time your system is available, is uptime divided by uptime plus downtime. So what does uptime plus downtime is the overall time you put your system in cloud without any means your system is fully done and you put it on the cloud. That means it is you are ready to use for the users, and you, whether it is uptime or downtime, you have already deployed your system. That total period is we have calculated through uptime, the time it is available, downtime when it is down. So that total time period is here, and uptime is the system is operational, is ready to use, it's functioning for the user. So that time we are trying to calculate that out of total time, how much time that the system was available for user. It is providing the required function or operation. So that we calculate here. And you can see I have given one example that suppose 300 hours the system was available and 15 hours system was down. So out of total time, 300 plus 15, 300 hours system was available. That means it is 0.952 or 95.2% time the system was available, right? So it is just a game, it's just a vague example that I thought I can put it here so that by numbers at least we'll able to understand that how exactly we calculate availability. Okay. And the nines of availability or availability nines is, I have given two tables. One is for 1 month, another is for 1 year. So usually when you have service level agreement, the cloud provider will say, you know what, we will give you availability of 3 nines or 4 nines. So what does it mean? So first thing, 1 9, it stands for there is only 1 9 in this figure. That is the 90% of time your system will be available. That means in a month, your system may down for 72 hours. That is whole 3 days. If it is acceptable for you, that's fine. Then they will have that agreement with you. But if you don't want, you can go ahead with further 9. There are 2 nines. That is 99% your system will be available. That is 7.2 hours in a month. So this calculation according to the month time. If you ask for 3 nines, okay, 99.9%, that is 43.8 minutes, your system will be down. As it goes down, as the nines are increasing, 4 9, 5 9, 6 9, 9 nines, you see the downtime is going down. Like for 9 nines, it's 2.6 milliseconds. 8 9, 26.3 milliseconds. But as the 9 will go down, your cost of the service that has been provided to you by cloud provider will go higher and higher. So that also a point to be considered, that you can ask, oh, you know what, I want 9 9 availability, but you have to pay for it. And does it justify to your business? That decision has to be taken. Most of the cloud provider or most of the systems are making use of max 4 nines, 3 to 4 nines, not more than that. Sometimes even achieving 9 nines, 8 nines is not even easy for cloud providers. They say they usually see to it that they will give you 4, 3, or 5 nine max, not even 5 nines, 3 to 4 nines. So that kind of availability they can provide. But achieving 9 nines is also not easy, and that's why it is too costly. Okay. Similarly, I have given another table here for a year. Just take an example. In a year, if your Facebook is down for 3 days or maybe 8 hours, we have seen in this news is Facebook was down for nearly 2 hours, how much money they lost. So imagine here, sorry, here, if it is the system is down more than 2 nines, 1 9, how much loss they will incur. So this is again another calculation for a year that if it is okay for you, we can go for 1 9, 2 9, 3 9, but it depends on business to business, system to system, that how much they want their system should be available. Again, here also same thing, 1 9, 2 9, and 3 9. Just keep one point, in mind that 3 nines means it's 99.9. Okay, 4 nines means 99.99. So there is a decimal point also in between, and accordingly the calculation changes. All right. So this is about availability, and our goal is to keep system highly available. And when we design a system, which we are going to do it in future sessions, but we have to keep in our mind that we should keep our system highly available, and accordingly we should plan that how we can make our system uh, available all the time by keeping these kind of strategy in our mind, that how we can load balance, how we can have replication, redundancy. If what happened, what should do we do so that even there is a failure in our system, how it will immediately get into shape to provide the required service, whether it is disaster recovery, whether it is scalability, all these points we should keep in our mind just to make sure that the system is available. And we will definitely look at how we can make all those things possible. All right. So any question on availability or something that is not clear? All right.
Yeah, it
So
is.
okay. So let's move to next principle, that is called reliability. Okay. So what is reliability? Is, let's again look at the definition as per the book. Then I'll give you uh, my definition of it. Reliability is availability over time, considering the full range of possible real world conditions that can occur. If a system is reliable, it is available. But if it is available, it does not mean it is reliable. In other words, high reliability contributes to availability, but it is not possible to achieve high availability with unreliable product. Because see, products may be unreliable, but it can be available by putting some repair time, see to it that you will have minimum repairs, you will have spares available. All this. So you can make system available, but it doesn't mean that system is reliable as well. The goal, what is our goal? Is to see to it that our system is highly reliable by maybe reducing errors so that there'll be less failures in our system. There'll be less security vulnerabilities also there. And we have to see to it that our system is secure enough so that user can use it, and there'll be less failures. Here is a formula also I've given that is called average time between failures. We'll look at it. But first we'll understand how it is different from availability. What we have seen through definition is a system reliability is availability over the time. In the sense, your system is available, my system is available for 99.99%, suppose. But with the user is working with my system, is having some security issues, having some errors, getting some failures. So will that be my reliable system where my user is trying to do something and it is failing? And if user is again, after some time again going and doing something, it is failing. So will it be reliable? No, for sure. Let's look at first example that will give a clear picture of it. See, I just put one example here that there is an online store like Amazon, Flipkart. which has availability of 99.9% when it launched. And first 2 years, it was giving this kind of availability. But when it launched, it has some security issues related to user information or maybe uh, credit card information. The user was happy, everything was going good, able to put buy and sell things, but they don't realize that it is unreliable. Means it is not reliable because there are some security issues, just like what user information or credit card information. And what happened in third year? The system started failing or was down because of this security instance. For example, maybe some of the user lost their, I mean, their credit card got some uh, some information got leaked, whether it is user information or credit information or credit card information. So that got leaked. And because of that, the system was down because whoever has designed the system, they have to go and check that why it is happening, why it is not working, why this information got out. So they have to keep the system down until unless they investigate, until unless they figure it out that why the information got leaked. And because of that reason, because of those reasons, the system was down. That means it is not available, but also it caused reputational and financial damage to customer. Though, then why customer will go and look at that particular online store again? Because they know it was available, but it is not reliable because it is not storing their information in a secure manner. There are some security issues. It is not available later on. It was available for multiple, not available for multiple times. So in that sense, even if your system is available, you have to make sure that your system is reliable in the sense of security, reliable in the sense of failures, and anything else that will make user think that, you know what, whenever I go to visit a particular website, I see that my data is available somewhere else also, which is not expected. Or I try to visit website and it is down because there are some other failures are occurring, and because of which I'm not able to. So these kind of stuffs are necessary. The system is available, it's possible. System is always available because there are multiple components that we put it into practice, and according to that, the system will be available. But whether the system is reliable or not, it all depends on how you make things work. See, there are the components that we discuss or the strategy that we discuss. These are also part of reliability. But apart from that, we also have to see to it, like monitoring, alerting. These are necessary because you have to see to it that how your system is moving ahead over the period of time, how they are providing the service, how secure the information of users or users transaction or users credit card, all this information are, how securely it is kept. If anything happen on user's point of view, on security point of view, you have to take your system down on by yourself to investigate that issue. And till that time, user will not able to use your system. So as here we mentioned, reliability is availability over time. A system is reliable means it is available, but if system is available, it doesn't mean it is reliable. So that difference you should know. Okay, and how usually we calculate reliability is what we call is average time between failure. That is the total service time divided by the number of failures during that services. For example, if your service time, suppose you deploy your system, which is available for next means, just I'm just giving vague example here, like 300 hours, your system was available. And in that 300 hours, there are 5 failure occur. Okay. So it's just a simple mathematical calculation. Is 300 divided by 5. That is 60 hours is the average time of failure. Like that means if your system started after 60 hours, there will be one failure. Again, after next 60 hours, there will be, this is an average time. I'm talking about average time. On an average, your system will be available for 60 hours. We have to see to it that how we can increase this average time. That means instead of 60 hours, if I make 120, that means my failure will be after 120 hours instead of 60 hours. So that is the average time between failure. We want to reduce the failure. That means we have to increase the time between these failures. For example, if this 5 failures become 3, that means your average time between failure will become 100. So that is how you make your system reliable so that user can make use of it. They know it is not going to fail for next 100 hours, 120 hours. So this is how you can increase the reliability. Okay. Any question on this? Are you looking for any other example? If you want, I can explain availability and reliability with another example. Is it clear?
Yeah, please explain with another examples.
All right. So let's take a quick example of your car or your vehicle, whichever you have. Okay. See, I have a vehicle which is my four-wheeler, which is in garage right now. So that means if it is in garage for some maintenance work, it is not available for me. But suppose my car is there in my parking where I can go anytime. I can start it, I can go anywhere I want. That means my car, even it is in parking, but it's available for me to provide me its service. Like I can go start my car, go anywhere, wherever I want. Okay. But if my car has some issue, maybe my tire is punctured, maybe whenever I start car, it gives some kind of noise to me. And whenever I start my car, or recently the problem that I have seen that I when I press key of my car, sometimes it doesn't open and I cannot get into my car. So imagine that reliability of my car. See, it is available for me to provide me service. I can take my car and go anywhere. So it is available for me to give me my service. But sometime when I press my key, my doors are not opening. So I will be always been under impression that if today if I go and if I press my car key and if it doesn't open, then I will not get that service. It will not be available to give me that service. I'm not able to drive it and go anywhere else. That means it is becoming less reliable for me. I have to take some action to make my car. Maybe I have to change my battery. Maybe I have to change my car key itself. Then I have to send that car to the garage and it will be solved. But until unless I solve that problem, my system or my car is not reliable for me because it can give me like I have some emergency and I have to go somewhere. But if I press my key and doors are not opening, I'm not able to drive it. So that is called reliability. My car is right now, it's not reliable because it's my car key is not working. It is available for me. It is there in my garage, in my parking, and I can go and drive. So it is available, but I am scared of pressing the key because it's not going to open door. So how it will be available for me if it is not reliable because it's not opening the door? I have to fix that problem. So that is what the difference. Even though car is available, it's not reliable because if I go someday, it will not open. So right now it is opening. That's fine. But some I have seen past that I tried to press key and it was not opening the door. So it is unreliable. There is reliable. So I have to solve that problem for sure. But to solve that problem, I have to take my car to garage and ask that people to resolve this issue. Maybe it is key issue. Maybe it is car's mechanism issue. So I have to solve that. I have to take my car down in the sense it will not be available for me in my parking. It will go to garage and it will get repaired and then it will come back. But that time will go, right? The time will be downtime will be there. That is what the difference, the real, I'm just giving a real life example which I'm facing right now. So that is what the example. It is available, but it is not reliable. And for getting the reliable car, I have to make sure that it is down. It is not available for me. I have to send it to garage so that it will become reliable. Is that clear?
Yes.
All right. So I hope these two concepts or principles are clear. We will look at more principles, what we've discussed today, availability and the formula, some news examples, availability of nines, and some strategy, and same for reliability. We have seen some formula, some example. So I hope this is clear. Maybe we will look at some more principles in our future sessions, but I would like to stop here. So let me stop recording.